The Conversational Flow, a KCAS podcast.
Hello, and welcome to the fourth episode of The Conversational Flow, an official podcast of KCAS Bioanalytical and Biomarker services. KCAS is a bioanalytical CRO serving the pharmaceutical and biopharmaceutical industries for over 40 years. Unlike KCAS' other podcast, the Weekly Bioanalysis, which features news and topics more generally associated with the world of bioanalysis, the Conversational Flow focuses more on the niche of flow cytometry and its role within the greater industry. My name is Adam Cotty, and I've been in the flow cytometry space for over 15 years. I'm here with my co-host, Brian Weil.
Thanks, Adam. I'm also a general manager here at the KCAS site in Philadelphia, and I've been in the flow cytometry space for a little bit over 12 years. Just a call out here, Adam absolutely nailed oh my goodness, that is very difficult to say. The bioanalysis wording there, and then we got that cytometry piece. Always a challenge.
I really have to appreciate you doing that for me after the difficulty I had on the first episode. So thank you. So Brian and I are members of the growing leadership and scientific advisory team at KCAS. Either or both of us are available to answer any questions you may have regarding this podcast or any of KCAS services. While our KCAS headquarters are located in Kansas, with additional location in Europe, we are both here in Philadelphia, and our producer is in Missouri. So we're truly all over the map. We are geeked to have you listening to the fourth episode of our podcast, which will be available virtually everywhere. Wherever you choose to find and play your podcast, you will likely find the Conversational Flow. We welcome all of you, whether you're joining us for the first time or if you're a regular listener to any of our other podcasts. Today's episode will be a review of the latest news and resources and a focus on a topic of our choosing before discussing any feedback we've received from you. We're constantly looking for topics, and we'd be happy to discuss something that you want us to cover. So again, we're fired up to have you here, and we are looking forward to a fun episode today. To kick us off for episode 4, Brian is going to go over today's podcast topic a bit before we jump into the news and resources section. Brian?
Thanks, Adam. We do have a packed agenda for today. So we'll go through some news, investments, and some exciting KCAS news. Then we'll go into our main agenda topics, which is really our philosophy on flow cytometry validations and how that relates to spectral flow cytometry. Then we'll go through a couple questions from the audience or feedback, and we'll talk a little bit about next week's topic. Of course, always with our weekend plans and favorite foods.
It sounds delicious.
So to jump right into medical news, the two things I wanted to cover today are protein degradation and Icaros. So protein degradation is a very interesting field. There's been a lot of investment news, of course, which is one of the ways that we get tipped off to it, but a lot of developments in the field and a lot of new directions. And we listed a news article there that was sort of explaining why some of this might be. And essentially, this protein degradation field, first of all, is exciting just because it has made some pathologies that were previously considered undruggable. Those things are now druggable. So that's exciting in and of itself. But the second thing is, when they are going in and doing some of this protein degradation work, they're actually seeing additional impacts from the protein degradation process that may have additional beneficial effects for things like cancer treatments.
Right, and so we're talking small molecules here, so accessibility, really, like you pointed out, it just is something that makes it a very useful therapeutic and exciting, as we're seeing a lot more of this, some termed as like molecular glue, for example.
That's exactly right. So and that's a good point, to go back to the beginning and talk about what protein degradation is. Mm-hmm. Basically there are all these proteins that are responsible for a number of different functions. Some of them are targeted directly at basically tying cells together, right? And then even tying different portions of the cells together. And those connective fibers are made up of proteins. And if those proteins are misfolded, then it can cause an aggregation, which can be a problem. So what this sort of field of protein degradation is using small molecules, using other strategies to identify these proteins and trigger them for degradation and removal by the cell. And it's an exciting new pathway that opens up new avenues from that perspective, and again has these sort of synergistic effects that people are extremely excited about.
Yeah, absolutely. I was excited to read about these things as an emerging technology and all the hope that they have moving forward.
Absolutely. And, it's because of this type of clinical research where they're really targeting a therapy at one indication, and then they realize that there's this whole other field that's always exciting. One thing that we haven't covered yet is, of course, the GLP-1 saga, which is a very similar type of, field that didn't exist beforehand, and then due to sort of a noticeable effect was then spun up. And then also, of course, the Viagra story, where it was originally targeted more at heart indications, and then we found additional uses for it as well. Always interesting to see what you find in terms of these unintended effects, as long as you're able to look for it, which is, of course, a good tie-in to our spectral flow talk later on.
Mm-hmm.
Also, in medical news, the second item was just the Icaros transcription factors in general. So this is a class of transcription factors that are essential for a wide variety of immune regulation. But specifically, we've seen a lot of research come out recently that is tying them into NK cell activation, development, and activity levels there. And this is an extremely exciting and important avenue of research, because the more that we understand how these cells see the world around them and react to it, the more we can then target therapies and fine-tune therapies to make sure that those NK cells are acting in exactly the way we need them to attack different indications.
Right, and these are essentially part of what's called a DNA zinc finger, and so are involved in gene regulation, right? And so being able to alter that regulation can have large impacts on therapies, as you pointed out, in this case specifically NK cells.
Correct. Yeah, absolutely. Zinc fingers are a pretty common class of molecule. They were one of the big hopes for gene therapy. That was, of course, before CRISPR came along. But definitely a lot of research has been done into zinc fingers, so we're very good at identifying them. And that's one of the ways that we were able to identify Icaros and its function relatively quickly and expand on that in the last few years. So definitely a well-known target for additional pharmacodynamic analysis, and something that in the flow world we are very used to looking at in terms of Tregs and NK cells and other things. Yeah, so we'll move straight from some of the medical research news over to some of the investment news. So very relevant. We do have, of course, the JP Morgan conference going on, which is like the Super Bowl of biotech investment news. So always fun there. We did want to start off with a little bit of a contrasting story, though. And this story is around layoffs and 2023. So 2023 was a rough year, just to put it lightly, in terms of biotech. And there we saw increases of 20 to 50% of layoffs in terms of biotechs that folded, or pharma companies that were retargeting their pipelines, and things of this nature. So definitely a very rough year there. And even in the fourth quarter of 2023, we saw quite a few impacts to a number of people.
Yeah, each of the quarters we saw an increase year over year from 2022 to 2023 in layoffs, essentially 57% year over year. We all know that the last year was certainly a difficult one, right? The economy going down as it had, and there's just not as much money out there to support things. And we saw this as in a decrease of IPOs and other metrics that you look for as far as health of job market and economy. Good news does seem to be that there may be some light at the end of the tunnel, certainly, with improvements coming and more jobs out there. Not something that is immediately fixed, but certainly will ramp up, is the hope.
Absolutely. I do think that is always the silver lining, that, as people transition from one job, either they take the knowledge and skills that they've developed at that job and go to a new place and really sort of leverage that to move that new place forward. Or, even better in many cases, they start their own business and, basically target their own thing. I know quite a few different drug makers that have, had products that they, are passionate about and think could make extremely good drugs that could significantly improve patient lives. But either the economics or the development or the specific, environment that they're in terms of the product mix at these drug makers may not be ideal for that therapeutic. So, that drug product may not move forward. But when they get the opportunity to then go out independently, sometimes this can happen. You can look at all of the Vants are a good example, with Samidavant and a couple others that actually purchased assets from large pharma companies and then were able to move them forward and turn them into extremely valuable assets after some additional development work. And there are countless stories like that. So while definitely layoffs are always concerning, and our heart goes out to our colleagues that are impacted by this, I am optimistic for what that means and what that could mean for the innovation landscape moving forward.
Right. And, some of the signs that the situation may improve are the pullback on interest rate hikes. And there have been a number of merger and acquisition deals, specifically some of the larger pharma companies. And so money's moving around, right? It would be an indication that things are freeing up a little bit. And with that, you led off with the JP Morgan conference, and there's certainly a lot of interest specifically in the M&A area at the outset of that. So do you want to talk about JP Morgan?
Yeah, absolutely. So far we've seen more than, I think the last count was over 5 billion, but it's going up daily in terms of how quickly companies are being acquired, partnered with, huge deals being announced. So definitely in terms of 2024 compared to this time last year, it is a different environment. I think people are really looking forward to that more flexible funding environment.
Mm-hmm.
So anytime that end stage is compensated well, then that speaks well for the initial stages too.
Mm-hmm. Yeah, and so it sounds like, I shouldn't say it sounds like, a JP Morgan event is invitation only, from my understanding, and injecting quite a bit of capital into the local area. So taking place in San Francisco. And so I think they're estimating somewhere in the order, let me see if I can dig up the number. No, it was quite large. I'll have to draw back if I can pull it up, but unfortunately, I don't think that I had written that down in my notes. Excuse me, but it certainly is a big driver. So lots of people coming in, all the hotels being bought up, and so a good event overall for bolstering the local economy there. And with that, it certainly highlighted a couple of acquisitions, one of them being Johnson & Johnson buying Ambrx. That was for $2 billion. It's a ADC company, antibody drug conjugate. And so we had touched on that previously. And the importance, certainly, the market is moving towards more and more ADCs. And then we've also got Merck closing on a deal for Harpoon Therapeutics, which is a T-cell engager. And so the thought there is that they're looking to offset some of the loss of exclusivity for Keytruda as that is coming up.
Right. So definitely you see all of these companies, J&J, Merck, BMS, even Lilly and AbbVie, actively looking for the next steps in their portfolio. Definitely a lot of these companies are facing patent cliffs where their highest revenue generating assets will be open to competition from generics and other providers relatively soon. So they're looking to really differentiate themselves in the field and come up with the next generation of therapies that will ideally drive medicine forward. You ask what is really driving innovation in the medical field, and patent cliffs, definitely a helpful thing there in terms of spurring on M&A activity.
Yeah, constantly happens, right? Things roll off and you get new patents there to replace them. The Harpoon Therapeutics T-cell engagers, tri-specific, so really interesting, engaging T-cells, cancer cells, and then has another arm for increasing half-life there. So a very interesting molecule.
Yeah.
Go ahead.
Yeah, just to talk back to the medical research news too. All of these therapies are more and more specific tweaking of how the immune system is interacting with various disease states. Just reemphasizes the fact that the more information you have about the pharmacodynamics of the indication, the more that you can design a better and better drug to get exactly what you need to tackle without impacting the rest of the body.
Yeah, and then going over to Ambrex, definitely great points there. Their drug, the primary candidate, prostate cancer, it's ARX 517, and looking at 50% reduction of prostate-specific antigen, specifically in their phase 1 trial, is about 23 patients, so over 50% of the patients there had seen that reduction. So really positive news there. And so with that brings us to our KCAS news. And so you'll notice I did say KCAS. Historically, I've always called it KCAS ever since, being legacy Flowmetric and having been acquired from what I had called KCAS at the time. It seems I wasn't alone in that. However, we are going through a rebranding of sorts. And the definition, since there had been even internally, some people had called it KCAS and some people had called it KCAS. We are KCAS Bio. And so, Brian, thoughts on rebranding?
I mean, I just don't know what I'm going to do with all the extra time saving those extra syllables by saying KCAS instead of KCAS, right? So, we're going to be more productive just off the bat. And we're all really excited about this rebranding exercise. We've gone through a lot of transitions as different companies, and we've done a lot of work on integrating. So we really think that this transition over to KCAS Bio is what we need to really reintroduce ourselves as the global organization that we've become, and really signify that. So I'm looking forward to it. I know we've got a lot of cool new swag, cool new logos and marketing initiatives going on. So looking forward to it overall.
Yep. And so if you see a business card from one of us, it's KCAS Bio. So looking forward to talking with you as a representative of the newly rebranded company. All right. And so then moving on, our next section, the paper of the month. And so we had mentioned that our topic this month is going to be on Spectral Flow, really near and dear to our hearts. This is something where I've been really interested in spectral flow. I would say back in 2017, first really aware of it and pushing to bring instrumentation on. I know we've kind of talked about this and hit on it significantly in previous podcasts, but it certainly bears repeating. It is at the forefront of technology for flow cytometry. And so for this podcast, we've picked the paper Full Spectrum Flow Cytometry in the Clinical Laboratory. With this, it's by Jonathan Brestoff. It was first published in May of 2023. And I need to pull up the actual publication name here. Brian, do you have the publication name handy? Apologies.
I do. So it's the International Journal of Laboratory Hematology.
Mm-hmm. Perfect. Thank you. And it has an impact factor of 3.453, which, if you're familiar with impact factors, that's a good realm to be in. And so it definitely indicates a solid publication. The reason I had to ask, just as an aside, I had printed this out. Yes, I am one of those people who enjoys having a printed out copy of a paper that I'm reviewing. And it evidently was bigger than the margins would allow and cut off just that part. So, but I do have all of my highlights and everything. Maybe that's aging myself a bit too much here. But I will say we're into new technology here and fully embracing it. So my age notwithstanding here, we're certainly at the forefront. Any comments on that, Brian?
You are a young spring chicken, Adam. I don't want to do ageism or anything like this. No, but as you say, we're definitely looking to stay on the forefront of technology here with flow cytometry in general. And I like this paper quite a bit as well because it's a nice, approachable way to really relay the advancements in spectral flow, yes, but then also talk about how to apply them in a different context where we really need a very robust solution and one that is repeatable and able to really stand up to IVD expectations here. So that is what this paper has gone through, and I think they did an excellent job of it. Yeah,
and when we talk about Spectral, they do point out several of the leading instruments ourselves here at KCAS Bio. We do have a Cytec Aurora, two Cytec Auroras, both 5 laser variety. Some of the other options you have out there, the Sony ID7000, the BD Symphony A5, and the Thermo Bigfoot. And so there's certainly different ways that you can go. This paper didn't break down the differences between the machines. Certainly, as mentioned, we have specifically picked out Cytec Aurora. Spectral Flow, though, it allows you to look at more markers, right? And so, how does it do it? Well, it addresses the emission spectral overlap and specifically looks at the fingerprint of each one of the fluorophores. And so it can distinguish fluorophores of up to 98% similarity, which is very impactful. So it opens the door for utilizing more antibodies, more markers, and getting more things into your panel to expand on your analysis. One of the examples put in here was for APC versus AF647, whereas generally in traditional flow, conventional flow, those are both picked up on the same filter set, and so you can't use them in the same panel. They're really indistinguishable. However, in Spectral, the fingerprints are such that there is enough difference you can use those in the same panel. And so those are a couple of the main points with Spectral. Another thing that certainly is very much appreciated is the ability to tease out autofluorescence. And what happens with cells is that they may have a brighter signal over baseline if they're activated, for example, and so have an increased fluorescence. And that can confound some of your conventional flow data unless you're specifically looking for it and pulling it out, which does take some work to do. Whereas you can do that utilizing controls in spectral flow.
Yeah, definitely a lot of advantages. One of the most interesting sentences I found in the paper was this one. In my personal experience, it is easier and faster to set up a 30-color experiment on a Cytek Aurora than it is to set up a 10-color experiment on a BD4 Tessa. And then, of course, a qualifier, at least in a research setting. So I found that to be a very interesting statement, too, because usually when you get that additional granularity, it comes with a lot more options, right?
Mm-hmm.
And you need to know what you're doing to be able to specify all those options. But here with Spectral, and I've heard this from a number of different users, I'm really not hearing that, where it is easy enough to use if you're familiar with flow cytometry, that you, in many cases, can walk up and start using some amount of spectral flow.
Yeah, and I think that was evidenced by us bringing these machines on. Granted, we do have scientists that have had experience with spectral flow cytometry outside of their career here at KCAS Bio, but the team, by and large, was able to pick it up incredibly quickly, owing definitely to the expertise. I know we've got a great team here, but just for how it relates to conventional flow, the processes they're set up. I would also say, too, the training that had been provided by the Cytek team and the videos that they offer certainly has helped enable the adoption of it. And I know our team absolutely loves running things in Spectral. So I can understand where the author of the paper, Jonathan, is coming from, and see what he means by that. Really do have to make sure that your controls are appropriate and single stain controls. The unmixing then is taken care of based on the use of those controls, and aids in data analysis. Now, the back end, I would say it certainly is much more, it can be much more time consuming for analysis. And that being because you are looking at so many more permutations than if you're comparing that smaller panel on a conventional cytometer versus the larger panel on the Spectral. And so there are programs.
Before we go into that, when you're saying that the data analysis is more time consuming, you're saying between a 30 and a 10 color panel, let's say. But if you were to develop a 10 color panel on both a conventional and spectral flow cytometer, the data analysis time on those identical 10 color panels
Yes.
would be nearly the same. Is that accurate?
Yes, I appreciate you clarifying on that. It's more of just the opportunity, right? The opportunity cost of how many different markers you are looking at, and while your conventional is going to top out at that 20 color, the 20 parameter, you're going, even in this paper, they're talking conservative 35, and going as high as 60s as far as parameters. So yeah, that's an excellent point. Thank you.
Sure. Yeah, and I think the two things that we always highlight in terms of the challenges of spectral flow versus conventional are, as you say, the development time and making sure that you got your unmixing covered. But then I thought that this paper did a good job of highlighting the other part, which is just the relatively less well-developed ecosystem. They specifically referenced controls and processes from regulatory agencies, which are not as well developed as with conventional flow. So they reference the CAP system, which sends out proficiency testing samples, and they basically don't have a process for Cytec or other spectral systems at this point, because everything is geared towards conventional flow. So just to say that, yes, there's the validation aspect, but then also there's a regulatory and standards gap that is being rapidly closed, but is still there at this point.
Right. And they did mention in Section 5 about specifically spectral flow cytometers in Europe having received that CEIVD designation. And so putting more rigor there.
Absolutely. But in our hands, definitely we've seen that these instruments are extremely robust. So, I guess just to jump into, our experience with spectral flow cytometry, we've seen significantly less requirements for, things like MFI targeting or things like that, because we're capturing the entire fingerprint. And by fingerprint, we are talking about the emission spectrum of the fluorescent dyes, where we can look at each wavelength at the same time. And really differentiate. So then we need to make significantly fewer adjustments to the instrument to run a given sample.
Right. And when you're talking about that part, I think then expanding out and looking at instruments across sites, one of the offerings is a harmonization of these instruments across the site, utilizing, what was it, a 40 color panel, I believe it was, right, Brian?
That's correct.
And so giving you the confidence that these machines are aligned and running as you would expect, similarly from one site to the other, one continent to the other, as we know, always getting requests for coverage, not just in the US, in the EU, additional requests, of course, the APAC region, Australia. And so you want to have confidence that these machines are analyzing samples the way that you would expect, and each machine similarly to the other machine.
Always have to have a good flow, indeed.
There's one pun. All right, so I got to call that one out.
Yeah, excellent. Appreciate that. So we've called out, I guess, the ability to standardize these instruments. We've called out the autofluorescence reduction. We've called out the fact that you can look at a number of parameters at the same time, and just the higher number of things. And in terms of the higher number of things, yes, absolutely, you can get exactly the answer that you're looking for. But going back to even the protein degradation question and some of the other examples we had there, you can find things that you weren't looking for too. So that's always an exciting thing, where if you have the data analysis bandwidth, you can do sort of unsupervised trees and find correlations that you may not have expected, and go back and really understand, is there a reason there or not?
Mm-hmm.
And I think you were also on the cusp of introducing some of the different software tools that there are to do that.
Yeah, and that's one of the things is a tool like this, as powerful as Spectral Flow requires more power, right? More analysis power. And you can have scientists sitting down and analyzing each parameter and going through. However, it would certainly be nice to have some sort of program. And in that aspect, even a program along the lines of machine learning. And so out there certainly are options, and investigating ourselves, right? I know several of our clients and potential clients have pointed us in the direction of OMIC as one, and having that component where you can apply machine learning, and that allows you to have a hybrid component to the analysis. The machine learning takes care of it, the front end, and then you have scientists reviewing and looking over, making sure that everything is as expected. And so you get the benefits of the power and speed of machine learning with the knowledge base of the scientific team, so that you're getting the best of both worlds.
Exactly. And, what a data management or data analysis system like that can do is really identify correlations and relationships, and then as you say, the scientists need to confirm that the manipulations of the data are correct, but then also they need to provide interpretation and context to say, yes, CD19 is related to CD20 expression in many cases, and that's not really an interesting insight, but potentially novel activation markers on Tregs could be a much more interesting insight if that was one of the conclusions that they came to.
For sure. And so, as mentioned, it's one of those things that we are evaluating. There are other options out there. There are companies that do that sort of analysis. It's amazing because I know several years ago, there was, I guess, less interest just driven by the fact that much of the analysis could still be done by hand and it wouldn't be a burdensome thing. But now, as machine learning has advanced and the power of computers has advanced, it's really opened people's eyes to what's capable. And then as well, time savings. There's only so much that one person can do in a day, and you put a tool like this in their hands, and really the difference between where we were 10, 15 years ago and even further to something like this is incredible.
Like the difference between switching from, as you say, manual accounting books over to Excel. Agreed.
Mm-hmm. So one of the other things I guess I wanted to highlight, you had written a blog on conventional versus spectral flow, correct?
Correct. So definitely one of the things that we wanted to advertise as soon as we got the platform in to say that, hey, here's what we can do, and here's how we're going to use this. So definitely we had written that initial blog, and would encourage everyone to read it and let me know if you have any feedback or updates that you think we should make on it. But then also we're in the process of coming out with another round of blogs and posts about our experiences with spectral flow, and ideally a few talks and posters in the near future, sort of highlighting our use of spectral flow on novel client projects here.
And I anticipate we'll continue this discussion, despite the fact that it has been a running theme. We'll keep on pushing it because it's something that we're very excited about, as the industry is, and continue to learn more about every day. It's funny thinking about our podcast and whatnot. I think we've got an overarching theme here, and I think you brought this up prior to we started recording, spectral flow and parsing out, identifying, teasing out small differences and whatnot. And then we've gone through the rebranding, and we've got KCAS, and, the difference, as you pointed out, between the way that you and I had said it before and the way you said it now, likens it to this running family commentary we have in the name Aaron versus Aaron. Now, I don't know that everybody's going to hear the difference of what I just said, because I know my wife does not believe that there is a difference. And I don't say that as a dig. I certainly, it goes both ways. But what I am saying is the name Aaron with an AA versus Aaron with an E. So parsing out that difference, I'm not going to rely on spectral flow to figure that out for me, but maybe we do some sort of audio to get to the bottom of if I really am saying something different.
And, to go back to the conventional flow way of doing things, when I had two different Aarons in my lab in grad school, and our lab manager would always call the one Aaron Aaron instead of just Aaron, specifically for that reason. So that's why, a conventional flow cytometer might need a second tube or a second A in this case to really drive home the differences there.
Yeah, that's good. I like that. I'm going to have to tell my brother that he is from now on
There we go. All right. Anything else we really wanted to highlight about Spectral at this point?
I think we've covered from a high level right? There's certainly a lot more that we can dig into. And I'm going to have to count how many times I said certainly in this episode. One of those things that every time I'm not intending to say it on purpose like that, but it happened. And so apologies. I will broaden my thesaurus there of similar words. But yes, we've gone through a high level. At some point in time, we'll go through and work on some things in more detail. It's just a lot of fun to mess around with Spectral Flow in that respect. But I do feel like we've given it some good airtime.
So in terms of feedback from fans and questions, we don't have anything else to cover for today, just getting off of the holiday season here. But we are definitely interested. So if you have any topics related to flow cytometry that you want us to talk about, or you want to hear answers to questions about, or you're interested in even joining us and talking about, please do let us know, and we're happy to cover that in next sections.
Yeah, and I'd love to hear from novices in flow cytometry, people who've cut their teeth in flow for a long time, either or, and anything in between. You wanted to provide feedback on how we're doing as a podcast. Love to hear it, even if it's for improvement purposes versus, you're doing great, whatever it is. So, looking forward to feedback.
All right. And with that, we'll jump into our wrap up. So in terms of our vaunted pun count per episode, I did review the previous podcast, and I was only able to identify a single pun.
Oh, so I walked in on you when you found the one, I guess. That's funny.
That was it. So we're gonna have to do better. As we spoke about, two dads in a room with microphones should be generating somewhere around 3 puns per sentence or so. So we will work more towards our punniness here.
Mm-hmm. Yeah, that's a resolution, right? We just started the new year. There you go. You just set us up with a resolution. Is that so? Resolutions. Do you do New Year's resolutions, Brian?
Every once in a while, I'll try. So for this year, my resolution is to make sure to improve diet by eating at least 1 or 2 completely raw or unprocessed fruit or vegetables per day.
That's a good one. Nice.
Right? Yeah. Achievable, right? So, not one of these workout goals where you have to do a bunch of work, just eat more stuff, or in this case, a different thing.
Yeah, I hear you. It's funny. The reason I ask is just it's been one of those hotly contested things in my family forever. One side of the family is totally cool. Well, I don't know. Do they like doing them, or they just are okay with doing it? I would imagine that at the very least okay with doing them. And then the other side is just so strongly against. And for myself, I'd always been one that I just wrote the resolutions. I will say that they always were a glimpse at my state of mind at the time that I was writing them. And when I say that, it's more so than just the actual resolution. It is, okay, I was driving to my parents' house, and on the cross Bronx, had somebody with road rage driving around causing havoc, and it was as frustrating as could be, and hitting potholes. And so by the time I get to the house, I'm just in a horrible mood. And so my resolutions that year were really not quite as rosy as one might anticipate. And then, having also been an English minor, had tried my hand at prose, and I would say that that was probably the sappiest year. Maybe I listened to one too many Chicago songs, some Journey, who knows? But definitely not against doing resolutions. But that's where my question was coming from. So then, as far as weekend plans, we've got the company holiday party.
Indeed. And, I know a couple of companies that do this where they actually have the holiday party after the holidays themselves because everybody's schedule is super busy right before the holidays. So trying to cram in a company event on top of all the personal events can be difficult. So I'm looking forward to it. I think it'll be a fun time. I have quite a few people that are able to attend, and even some of the commercial staff will be in here joining us operations folks. So looking forward to it.
Yeah, it'd be exciting. I don't know that I've been to this place before, so looking forward to it. What kind of menu do they have? Have you checked it out?
I have. Looks like some excellent food choices and some beverage choices as well.
No, you can't go wrong there.
Right.
All right. Excellent.
So in terms of other business, our next recording will be, of course, episode 5, and we are going to be looking at novel applications of flow cytometry. So weird things that you can do by looking at how cells glow.
And I will say this is another fun one for us because we've been asked over the years to apply flow to many different either matrix, sample types, whatnot. And it's a challenge. You want to be able to get good, reliable data. And, the team's had a lot of success there. So talking about some of the things that we've been challenged with.
Looking forward to it. We'll see you then.
Take care. Thank you.